Hello, and welcome to another episode of Hacking with Friends. Today, we're going to do some really exciting stuff. And I'm joined here today with Michael, who is our chief cable dragger over here at our production team. Michael?
Hi, this is Kody, our official dingus of the studio.
Okay, and I'm a security researcher at Varonis. Michael's vocabulary is sometimes a little bit limited, but today we're going to go into a topic I really like, and I'm going to be dragging Michael along the way. We're going to be learning about target enumeration, and actually we're going to hack a target today using mostly Nmap. And the reason we're going to be using mostly Nmap is you can't hack what you can't see, so we are going to be focusing on identifying a device, focusing in on it, discovering an open service, and actually breaking in. So this should be pretty fun today. Michael, have you ever done anything like this before?
Not really, actually. I know enumeration is like one of those subjects that kind of gets glossed over. Like, everyone's all into, like, how do I hack Wi-Fi? All the, like, sexy parts of hacking, and then they're like, okay, I got access, now what I do.
Yes. So really what we're talking about today is what happens when you find an Ethernet port that's just open and you can connect to any network that, or anything on the network that's connected. What if you find a Wi-Fi network that's not properly secured, where it's just by default open and you can scan around on it? There's lots of different reasons why you might have open access to a network with lots of stuff on it. And one thing I should caution you before we do this is that some of the stuff we're going to be doing will definitely be illegal if you just happen to do this, for example, on your school network. So while scanning is okay, if somewhat suspicious, there are other things that are not. And in fact, depending on where you are, scanning can still get you in trouble. So I've brought this up a couple times, but I was shocked to learn that you are not actually allowed to directly scan a computer that you don't own or don't have permission to in Germany. So they have to rely on tools like Shodan to do the scanning for them and then just subscribe in order to get the results.
So is Shodan technically then doing illegal scanning?
Well, they're located in the United States, so if they happen to have German customers who are subscribing to a United States-based company's data, then it's a loophole.
Yeah, that's a loophole.
Yeah, I mean, it's one of those things where, the data's out there and you can subscribe to it. You just can't actually go out and do it yourself. You need a third party to do the scanning. Right. So if you live in the United States, then you can pretty much scan whatever you want, although you might get some unwanted attention depending on what you're scanning. And we need to get into some scope here, because when I talk about identifying targets and stuff, people who aren't familiar with networking are always kind of misidentifying whether we're talking about internal or external network stuff.
Right.
So first, let's say that one part of my job is from the complete outside of a network without having a password, identifying different devices that are nearby, maybe which network they're connected to, and maybe even cutting one of them off from that network and hitting them with a phishing attack to try to break into the overall network. That's all external network stuff. We don't need to know the password. We can't really see the contents of the communication, but we can see metadata, and that's enough to give us a very clear indication of what's going on. Today, we're going to take a step even further, and we're going to look at internal network stuff. So let's say that based on one of our previous guides, like the one where we're popping up a phishing page on someone's phone, trying to get the network password, we succeed. So now we're actually part of the network. We can join, we can decode traffic, we can actually do stuff. What would a hacker really do here? And that's what we're going to focus on today. Internal network stuff, where we're basically assuming that we're ending up on a network that might be vulnerable, it might be open, it might have juicy stuff on it, and we're trying to get around the network, identify things that we're interested in, and maybe even, do something nefarious or something bad when we identify a target. And today we're going to be hacking Michael's Raspberry Pi.
Okay.
Yeah.
Cool. This magical Raspberry Pi that I set up. Yes.
Yeah, so Michael's Raspberry Pi is currently behind us. It is running, I think, Kali Linux, and we're going to be breaking into the SSH connection of this really nice tool. And hopefully you will know that it worked, because we will get the screen behind us to light up or flash or do something when we reboot the device. Yeah, I just thought of that just now.
Okay. It's like we planned it all along.
Right? Yeah, so, okay, we're going to be deploying a couple tools here. So let's say that I've gotten access to this network. How? Well, maybe they left an Ethernet port open somewhere. Maybe we have gotten access to the Wi-Fi password. Maybe we've cracked it. Maybe we phished it. Doesn't really matter. We're in the network. And now we can start to do bad stuff. Well, what are our tools? What are we able to do? Well, first we're going to use Nmap. And we can also use something called ARP Scan in order to take advantage of two network features. So doing an ARP scan takes advantage of address resolution protocol messages, which are basically trying to figure out who is connected to which IP address and making a list of these relationships. Now, we can perform a scan if we want to know everything that's on a network by just inquiring for every possible IP address on the network and saying, who's here? And basically, anything that's on the network that is there is supposed to reply to us. And this is a mechanism to, amongst other things, prevent collision, make sure we don't get the wrong IP address, and also make sure that messages are sent accurately. Now, there's attacks that are based around ARP spoofing and doing that sort of stuff, but today we're going to be using ARP the way it's intended, and we're just going to be using it to discover other devices on the network. So this is the first scan that we'll do.
And so that's how the whole scanning process works then, is what I just ARP for like all the IPs on the network, and then I go to each IP and ask for each individual port, or?
No. So the ARP scan is going to be our first mechanism of discovery. This is just going to be something to reference and figure out the network range. Now, of course, we can just join the network and then infer the network range from the IP address that we're given. But in order to just kind of see what's already out there from one layer, then we can just do a simple ARP scan, and that'll allow us to do a very fast scan that shows us the results very quickly. Now, if we want to go into something more complex, that's when we're going to move into Nmap. And with Nmap, we can do things like, once we figure out the network range, scan the entire network in sequence and figure out if there are any services open that we really want to start poking around at. So we'll move into Nmap, and then we're going to start looking for targets that run services we know might be vulnerable. Now, if you don't use an SSH key, instead you use a password, Michael, could you explain why that might be a bad idea?
Well, you can brute force those passwords
You
pretty
can.
easily. Which is why I always recommend people fail to ban is a thing you can install on your SSH so that it like bans you if you get 5 failed attempts.
Right, so brute forcing, for the unaware, is something where we're going to try out a whole bunch of passwords in order to try to break our way into this network. And I actually came across this while I was looking at something about Emotet today. The way that it was breaking into other devices and figuring out how to spread itself really intrigued me. So I've been looking into ways of kind of replicating this behavior and showing off some of the ways that these IoT attacks or other ransomware attacks work. So this is something that also is integrated by a lot of really advanced tools to do brute forcing against networks or services. So what we're going to be demonstrating today is something very similar to what something like Emotet would do after it managed to get into a new network and it was trying to propagate itself by looking for vulnerable services. All right, so let's go ahead and switch over to my screen. And we have a couple essential things we have to set up first.
So dark and spooky.
I know. Well, it's almost Halloween-ish, sort of, according to every grocery store. All
Whoa,
right, so
is that a password there?
yeah, what is this? So, all right, we have a whole bunch of passwords in our password list, and this is something that we're going to be using later. I just wanted to show off that, you know, whenever we're starting out with brute forcing attacks, it's always good to have a base of passwords that are really, really common. Some of these are more common than others, and I've also seeded this with one I happen to know may just work a little bit later on, just to demonstrate how all this happens. But in general, you'll need a good password list, and I recommend for those who don't know anything about this, just Google WPA2 password list. That's where I get a lot of my good ones if you're doing WPA2 stuff. Otherwise, you can find common logins for just different operating systems and stuff, and you'll find that the ones that are default are the ones that perform best. So here, we're going to be taking advantage of a password that has been left default. So what that means is when we set this up, we never bothered to change it away from this exact same login and password that every other Kali Linux device now uses. So unfortunately, that means that it's very likely that this login pair is going to be in our brute forcing list.
Ironically, too, like I feel like it makes a lot of script kiddies or newer hackers vulnerable because they'll install something like Kali and just leave everything default because they don't know to change anything, perhaps?
That's correct, yes.
And so, ironically enough, by trying to be a hacker, they actually make themselves more vulnerable.
Yep. All right, so right now we are connected to a wireless network. And what we're going to do is first we're going to scan, and we're looking for a Raspberry Pi device. But let's say that we have just joined this network. We have no idea what is on it. Do I have IP calc? Yeah, I sure do. Okay, so let's say that you're brand new to network and you don't know anything about the way that this stuff works, and all you know is that you have an IP address and you don't know what it means. So I'm going to do ifconfig, and to be kind to Michael, I'm going to try to omit information that might upset him and he might have to blur. Let's see if I manage it out. So I'm going to do ifconfig grep 192.168, because that's what I know that the IP address starts with. So here we go. So my IP address is 192.168.1.101. Well, what does that mean? How many IP addresses are possible on this network? What is, like, if you don't know any of that stuff, you don't want to do the math, you can type ipcalc. If you're on a Linux system or a Mac OS system and you have this installed, then the IP address, and look at this. It gives you all the information about this. It shows you the network range. You can type this in order to scan everything on the network. It tells you the minimum, which is usually where the router is. It tells you the maximum, which is the largest, the highest IP address that is able to be assigned. The broadcast, so you know that this is going to everything. So, and it gives you the total number of hosts per network. So you know this can support a total number of 254 different devices connected. That's how many IP addresses it can give out. Isn't this useful?
Yeah, like the thing that's always confused me is like the /24 or / some number at the end. Like I don't understand like what the purpose of that is.
So it's a network mask. So here you can see that the network mask is 24. So if you look at just the bytes of the network mask, it's 255.255.255.0. So there's only basically IP addresses in this range that are available to be allocated. So when we're doing a network scan, we can just do 192.168.1.0, basically starting all the way to the absolute minimum. And then we're saying /24, and basically we're giving it a subnet that says this is the range. So the entire last octet is what you can go up and down. So we're basically passing it a filter. Is what we're doing there with this.
Okay, that makes a little more sense. But it's some of that weird like byte math going on there.
Exactly. So
because I'm like /24, how do you get 255 possible IPs out of?
Yeah. So the literal of it is spelled out right here. This is what your actual IP address is. If you're interested. IP addressing is not that hard. I'm not going to go too much into it today because there's this great tool for people who want to cheat and just be able to get through it. To be able to find this out. But yeah, I think that IP address subnetting and stuff is something anybody would do well to learn a little bit about because it makes navigating networks really, really easy. Right. Some of the commands I'm going to show today do not require you to have a subnet or an IP address or whatever. You can just type them and they will work. And that's why I like them, because they're beginner friendly. But other network tools will specifically require you to know the IP address that you're looking for. And for a new hacker, someone who hasn't done a lot of networking stuff, it's super confusing. You don't know how to like find stuff on the network. You don't know where stuff is. You don't know where you are. So this network range right here, this is what you need. And in general, if you're on a commercial network that's like just in the United States, you're going to see something like 192.168.1 something. Yeah. And the 0/24 is the shortcut to scan the entire network. And that includes everything possible on that network.
And that's why I always say, like, if you're getting into ethical hacking, like, I strongly suggest, like, setting up your own home network, doing pfSense, whatever you want to do, just because you're going to force yourself to learn more of this networking stuff, right? Because that way, when you do, like, crack the system, then you aren't, like, a lost ball in high weeds. You're like, oh, yeah, here, I just need to, scan the network, do this and that. And you're not like, what IPs? What is that? Yeah.
Yeah, so shout out to Vis, by the way, because I believe he's the one that taught me this little trick. Very handy. So, okay, so we have the network range, but let's say that I'm a total beginner. I don't even know what this means. I just want to find out everything I can on the network. Well, let's do the ARP scan that we were talking about before. So I've updated macOS, and Wireshark has gotten very finicky. But I'm going to risk it all and see if I can possibly look on the network and see what this looks like.
Crash the system. Can you make that terminal window?
It won't matter because Wireshark is going to launch right now. Okay, let's see what happens.
That's so tiny.
No. Okay, cool. All right, so it's running. I'm going to minimize this. Whoa, get small. Get small. All right. And then Wireshark, where are you? Why are you? Okay, I'm going to put you over here. So hopefully what I expect to see is a bunch of ARP packets go out when we do an ARP scan. So let's talk about ARP scan. Man, let's see if it has a man page. Yeah, cool, it sure does, but it's not big enough. There. So ARP scan, the ARP scanner, very useful. So it explains how it works. Basically, you can use the localnet command to identify the IP address that you have and then scan the entire network range. It does it for you. It's so handy. It's so useful. So there's a bunch more information. This is actually a very powerful, very useful tool. You can see that there's different things you can do with it. Oh my gosh, there's so many different things you can do with it, but I'm not going to do any. I'm just going to do ARP scan, sudo ARP scan, hack L, that's the abbreviation for it. And then when I press enter, I expect to see on this side a big flood of ARP packets. But let's see.
And so I know in previous streams and stuff we've talked about Fing, which is an app on your phone that does scanning. So is that essentially what Fing is doing? Is this kind of...
Let's take a look. So we'll take a look with Fing. Hold on. Let me go ahead and move this over. And
for those of you that might not know.
Look at this. So we have tons of ARP packets going out. What are they saying? What are they asking? I demand to know. So if we want to take a look at this, I can double click. Address resolution protocol. Yeah, so it's basically asking, and actually let me close this and go to the main window because I like the way that they sum it up. The messages are like kind of like simplistic and funny.
I like the protocol name. That makes it super easy to realize what's what, at least to some degree.
There's more information here, I know it. Okay, so you can see here that sender MAC address, sender IP address, target MAC address, target IP address. So it's sending to broadcast. It doesn't know who it's sending it to, but it's targeting a specific IP address. It's basically looking at this one in particular. So that is the behavior that we're able to actually see. And you can see it's doing it in sequence. So it's targeting every single one by one IP address.
Yeah, so basically it's just shouting out to like a parking space and being like, hey, is there a car there? And then it's like...
Exactly. Yeah, there's another way to show source, destination protocol, transmitter, text item? No, maybe.
But yeah, what I was going to say earlier is Fing is an app you can download on your phone. I think it's on Android and Apple, but I know it's for sure on Android. And it's just a very simple way when you're connected to a Wi-Fi network to scan it really quickly. And then it'll allow you also to port scan individual devices as well. Super useful anytime you're working with like a Raspberry Pi or like anything that's joined to the network and you need to address it by its IP and you don't know where it is. Also, like, just if you want to, mess around with your friends and you have their permission, like, you can port scan for IoT devices and stuff like that.
Yeah, so, okay, I'm not going to dig too much into this. It's basically just asking a series of questions. Usually, when you look at these packets, it literally is just saying, like, hey, who has this? Tell this. And that's really what this is saying. It's asking a question and demanding a response from anyone that's at that address.
That is so many packets.
Yeah, it is. So let's take a look at what we found. A ton of stuff. Lots of stuff. Yeah. So
just a few devices connected.
Looking at this on this column right here, we can see that we've identified some stuff. Like we found a Dyson. This like we found maybe a vacuum cleaner or something. And then we've also found some stuff that might be the router.
I think I know what all the unknowns are.
We found a Roku, a streaming device, but we don't know the manufacturer of all of these devices yet. We just know which of the IP addresses on the left side are occupied. So this is good for us because there is information here, but we don't quite know yet what is going on. So one thing we could do...
Well, I was going to say something I think we covered in the PFSense stream is maybe you shouldn't always trust those MAC addresses. So like we have a good idea of what the device is, but it could be saying, oh, I'm a vertical launch system from Lockheed Martin, but clearly I don't think we have one of those hiding in our basement.
Who knows?
Yeah.
But yeah, no, we don't. So what we're going to do next does require us to know an IP address. So we know what our IP address is. So let's go ahead and do a search, but this time we're going to do something a little bit more general. So we're going to do an Nmap scan, and let's take a look at man Nmap. And this is always a good idea if you're going to be using a new tool, just looking at the man page if one is available. So Nmap, network mapper. Did you know that that's what it stands for?
Wow. Yeah, that seems like...
Amazing.
Like common sense, but you never thought about it kind of thing.
So I'm going to open this a little bigger. So we can see that there's tons of different scans we can do, and we can see some examples.
Wait, are these all example scans?
Some of them are, which is great. Scrolling through, options summary. There's so many options. Operating system detection, just like all this stuff. Target specification. Man, like
I feel like this is the kind of thing you want to pull up a GitHub page for to read.
No, the man page is pretty good. SN, PN, port list. So, and it describes how it does it as well. So if you want to know the methodology behind any of these scans, then, it's really helpful to know them. And then if this is overwhelming too, I believe you can just do nmap tac h. Look at that. Can I just say that, don't trust developers who, when you type tac h, they pretend like they don't know what you mean. They're like, oh, error, do you mean help? And it's like, do you really need me to type out all those characters to know that I want to see the menu?
My poor pitiful soul.
I'm sorry. It's antisocial programming. Okay, so over here we can see a big condensed list of all the stuff you can do, and it gives you some examples as well. And then at the bottom it'll give you some real examples you can just type in and just go. Okay. So in fact, if we want to take a look at nmap tac v tac a scanme.nmap.org, you can see, wow, it's doing a bunch of scanning stuff. It's loading a script.
Oh, yay, open ports.
Scanning services. Yeah, very nice. Okay, all right. And of course, this is just something that you are allowed to scan. So if you want to go ahead and scan this, it's literally scanme.nmap.com. Okay. So you can see, wow, tons of information. The SSH host key. Oh, you can see that there's an SSH port open. Interesting. And then it's running Ubuntu. Interesting. So again, this is not on our network. Feel free to knock on the door of this because it's not ours. But this is a built-in example of how you can use Nmap. And if you want to get started, I feel like they don't really care if you scan their stuff.
An important note I feel like about this is a pretty loud process, right?
It can be.
If you're monitoring the network, you're going to see a ton of traffic.
Well, okay, it really depends on what you want. Look at this stuff. The way that you're able to do a scan here, there's so many different options. If you want to go low and slow and try to do something that's not going to be detected, you can do that with Nmap. You just need to get into the weeds a little bit and do some of the stuff that might not be as common. So, okay, let's go ahead and do a very basic scan. So let's say we have no idea what we're looking for yet. All we know is that we want to look for something interesting. Michael, what do you think would be the sign of something interesting, like a device that we could mess with? One or two examples.
Anything with open ports. I particularly open SSH or FTP.
Or what other kinds of ports might be useful for controlling a device?
Internet, HTTP.
Yes, 80.
81.
81.
81.
And 8081. Those are the best ones.
Okay, yeah. Those are all the internet ones.
Those are all the internet ones. So what do we mean by this? What does Michael mean by internet port? Well, what he means is a web server. Isn't that right?
Yeah,
that means that there is a interface.
It's not technically connected to the internet or whatever, if you want to get pedantic about all of that.
Pedantic. If you want to get correct about it. Yeah, so basically what it means is that if we find a port that's open and it's on a certain port that tends to be reserved for web servers, there's probably an interface being offered up for you to connect to. And you would never know that this is the case, but a lot of the time, if you go to a coffee shop or something and you do a scan like the one I'm about to do, which you might not be allowed to do, you'll find that there's ports open on things like security cameras or all sorts of other stuff that shouldn't be open. And sometimes if you just go to that port, which we'll show how to do, you'll find that there's just something there. Sometimes it doesn't need a password. It can be pretty surprising to see that, you can just make the printer do a test page anytime you want in another office upstairs just because they're on the same network.
And so many times, even if there is a password, it's default stuff that it's ridiculous. And oftentimes when you do scans like that, you'll find router login pages that I've been, at friends' houses. I've had permission to scan networks, and these are internet people. These are tech people, and I'm like, you haven't touched your router ever. You haven't changed the default admin or admin password. It's pretty ridiculous. And then a lot of times a lot of the devices will be like that. Printers are another very common one.
Yep. All right. So what does this look like to you? I'm going to make this big.
Well, okay, sudo.
Whoa. Hold on. Why it hates it.
What have you done?
There we go. All right.
You broke it.
All right. So what does that look like?
Sudo, I'm going to, as an admin, run Nmap on the IP range of the default local network range, other one being like 10.0.0. And then I'm going to look for ports 80.81, 80.80, and 80.81.
That's it. Boom. Let's see what happens.
I don't know. Oh, yeah, TAC-P is, I guess, for the ports.
Yep. So we're just saying that we want to see this, but I've made a fatal mistake, a noob mistake. I have said that I want to see everything, the status of everything on the network, regardless of whether or not the port is open or closed. So if I'm a hacker and I want to find out, like, hey, I want to find some stuff that's open.
Oh, so you want to
look at all this bad news I got. Closed, 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 closed. We got one that's open, but this is not a very condensed report. If I scroll up, every single thing on the network is listed here. So like cool, but there's a better way to do this. So let's go ahead and rather than tediously go through this, let's just go back up to our last command and do -- open. Wireshark or a net. Oh my god. Nmap is beautiful.
Yeah.
And we're going to redo this scan, but we're just going to say, like, anything that doesn't have something interesting going on, just omit that. If it's closed, if it's filtered, like, you know, I don't want to see it. And we can also invert this if we want to just look for closed things. We can do that as well if we so desired. But look at this. All right, we found only things that are open. This is a much more condensed report. Everything here is a positive hit. So we have some unknown MAC addresses. We have, concerningly, some sort of interface open on our Roku. God knows what that is. Let's go ahead and
I'm sure that's safe and mundane.
Yeah, great. So we can see there's a friggin' printer connected. That's wonderful. You know, all this great news. So, okay, let's say that we want to look at the, what's the least harmful thing? Let's go ahead and look at the Roku, right? Why not?
Yeah, sure.
Okay. All right. I'm nervous now. So let's see if I can just open. Will it let me? No, it hates it. I have to actually, you know, do it in a real service.
A browser.
You're so tedious. You know what I mean. Okay, fine. All right, so let's do this 192.168.1.165. It's gonna do. Oh, and it immediately challenges us. Admin. Who knows, right?
I wonder what are the like default.
It doesn't work.
Roku
but if I cancel it, then like I still, you know, it takes me somewhere. I also know that it goes to 8080. So if I do 8080, okay, it doesn't want to give me anything. But the point here is I can start to attack this. I now am able to start, you know, messing with it. I'm able to start trying to log in. Suddenly, I might poke around and find something
that's
valid.
very easily brute forced.
Yeah, and what the heck is this, right? 192.168.1.244. Very suspicious. Let's go ahead and find out. Connecting, and
oh, you might find my Plex server.
Yeah,
too.
we could find all sorts of
I was going to say,
stuff.
don't open my Plex server.
I may not. All right, we're going to go ahead and run this. URI doesn't exist. We found a light bulb, ladies and gentlemen.
Oh, okay, you're going to find like 20 of them.
We're going to find, no, most of them are not online. What is this? Another light bulb. So this is an API. So it requires a little bit something extra for us to interact with it. This one, another port 80 open. What's this? A printer! Hooray! And it looks like it was designed in 1999.
Holy cow, that is...
Change administrator password.
Oh my.
All right, guys. All right. Can I tell you, this is the #1 thing you can expect to find on public networks if you do a scan like this. You're going to find some wonderful person who very trustingly has just plugged in something like our brand new printer and decided that, you know, they're not going to set it up. So now if I wanted to, anybody on our network can set up this printer. And if this was put in a public network, that means if you are able to find this IP address and this port being open, you could too. So is that good? No,
it's not
like because whoever finds this first owns your computer, like or owns this device. Like they can change it to whatever they want, and they can terrorize you with all sorts of printer shenanigans.
You know, in the ransomware video or live stream, I jokingly talked about how we're gonna get to the point where it's gonna be like ransomware devices, and I feel like this is that perfect example. Is like you could just write a script that like scans all the publicly available networks for printers. For this page, if it has it, changes the password and then prints out a sheet of paper. If you want this printer back, give me 2 Bitcoin.
Okay, so we have a clue here. It's recommended to communicate via HTTPS for entering an administrator password. Do you remember the port for HTTPS, Michael?
No. Shameful. I know. I can't call myself a hacker now.
Is it 446 or 44? No.
I can look it up.
Okay, well, no, we're not going to friggin' look it up because that is the whole point of Nmap.
Okay.
So let's do sudo nmap.
Nmap. What is
And then just run it. Like, I'm not even going to do any arguments. And it will do a much more invasive scan.
Hey, 443.
443. I was so close. 446. I was doing 443. I was very close. All right, so it's not it's not opening anyway.
Let's see if we get a better.
Oh wait, no, not /443. Colon 43.
Yeah.
Okay. So
And
it's still not secure.
That's great. Well, let's just.
Could it be though? HTTPS. Just trust me. Just do it. No, it hates it. Okay, so that's very funny. But you guys can see that like there are things that are left open that are kind of sketchy, and like this is the reason why finding stuff on here is a good idea. So let's say that we are more interested in. Okay, let's run another scan. So there's some other flags we can run. So SV, what does that do?
I don't know.
Yes.
Scans for Veronuses?
Yes. This is the scan for Veronis. And you can tell by the capital V.
Yeah, no, what else could it be?
Okay. No. So we just did a service scan.
Okay.
So what we're able to... So as you can see, we weren't able to detect any Veronuses with our scan, but we were able to detect other services running. So what's interesting here is this sort of scan will go through and look for different services running on ports. So we can see Jet Direct. That sounds like some printer crap.
Yeah.
We have TCC wrapped. We have printer, TCP wrapped.
Printer definitely sounds like a printer.
Yeah, it all sounds like very printery stuff. So if we wanted to do, let's say we want to do...
Although, that would be great if you were to implant a rogue device on a network and just name it printer. Because no one would suspect that. Who would suspect the printer? Well, I guess that a lot of printers do get compromised, so they might actually suspect that.
Okay, so this is what we did. So we just did a scan now where we did -O. What do you think -O is?
Open.
Operating system. So we attempted to figure out what the operating system is behind this stuff. So with this scan, where did it go? There's so much green, I love it. Okay, yeah, so sudo nmap -pn, and this gets around port blocking, -O to attempt to identify. And then, so first we see all the stuff that's open, all kind of similar information, but then Linux. Our printer is running Linux. In fact, it's running DDWRT version 3.0. Linux kernel 4.4.2.
That's pretty cool. So that's why it would be pretty bad to compromise a printer, because you basically have a full embedded Linux system on the network now, right?
Well, I mean, yes, but also if we have any vulnerabilities, if we know anything about Linux, about this particular version of Linux, then, you know...
privilege escalation on that particular version of Linux, I'm sure you could look up and find.
Yeah, so, you know, if we do this, CVE, you know, maybe we could find some sort of problems with this. Yeah, like a list of vulnerabilities related to this, and we can see, like, okay, does this affect, like, a version of Linux that's recent? Looks like there's nothing that's super recent, but, you know, this is a way that we could potentially find an exploit and go after this. So this is how hackers will start to enumerate stuff and find out more information. So this isn't what we're going to look for today. In fact, how far in are we?
We are 33 minutes.
All right, guys. So now let's go ahead and get into the actual exploitation stuff. Let's go ahead and find something we can try to break into. So, Michael, if we were going to break into a service, aside from FTP, file transfer protocol, what might you look for?
Well, we already discussed like HTTP, like web servers. So SSH would be like another natural one.
There you go. Let's do that.
Especially. Yeah.
All right. So what port is SSH on? And of course, you could always change this port to something else. But if we're scanning around and looking for services running, then it probably wouldn't help, right?
Of course, you put me on this. Is it? It's 90 or 40 or something. It's like a 2-digit one. I forget.
Yeah, it is 2 digits.
I don't remember.
And one of the digits is 2.
22?
And the other digit is 2. Yeah. All right. So it is port 22. That's default. So let's say that we don't know if any devices have port 22 open yet, do we? So we need to use friggin' Nmap for that. So let's do it.
Like something I've talked about in some of the videos is these port numbers are more a matter of convention than they are like law, right? So like technically I could have SSH running on like 9,999, right? Or any number.
Yes. But I can also just scan any target on every single port and just see what services are running. It just takes longer. 10/24.
And when we say longer, are we talking like just seconds longer, or would that like take substantial.
I've already forgotten what you
Yeah.
asked me. Hold on. Sudo nmap hack-p22 -- open. Okay. What was your question?
So you were saying it would take longer if you wanted to scan like every port.
Yes.
But
so,
that would only be like a couple of seconds longer, right?
No, it would be like another minute or two.
Okay.
Because you're scanning every port on. So think of it as like enumeration. For every device you find on the network, you're scanning
Right.
like 9,000 ports, as opposed to for every
Gotcha.
device on the network, you're scanning one port.
Yeah, so you could say like your first pass is you would target specific ports, but then if you want to do a deeper scan, you can do like every port and see if there's any like sneaky SSH hidden servers on there. And like on your own server, if you are worried about some of that stuff, I mean, it's not that much protection, but you can always put it on another port or something.
Yeah. Okay. So let's go ahead and run this one. So what is this going to do, Michael?
We're going to scan the network for port 22 and only show the open ones.
Yep, that's it. So let's see what happens. Once we get that back, we can select a target, and hopefully we'll be able to learn a little bit about the operating system and maybe identify, hey, our Raspberry Pi.
Nice.
All right, so we've identified 215. So let's go ahead and nmap it.
Okay.
Nmap 215.
And isn't the SSH server disabled by default in Raspbian? Or, well, I guess this is Kali.
It is Kali, and it's
Yeah.
open by default. So I'm also going to
Interesting.
do this invasive where I try to identify the operating system. So maybe it'll identify it as Kali Linux. Maybe it won't. Who knows? Let's see how good Nmap really is.
It's
Probably going to just identify it as Debian, if I was
Yeah.
going to guess. But if it manages to profile as Kali Linux, that would be hilarious.
It's interesting that
Whoa.
Kali doesn't do anything more to secure SSH by default.
Well, you can, and it sort of does. I think you do have to open it, maybe. I'm not sure. No exact OS matches for host. Very sneaky, Kali Linux. So it's...
So what's this TCP fingerprint thing we're looking at?
I have no idea, because this is like Apple Darwin, and there's no Apple anything involved
Right.
in this. But maybe it's obfuscating itself. I don't know. Who cares?
Okay.
Although I suspect that it's actually a fingerprint from here or something. So, all right,
Gotcha.
so we have this. Let's do one more scan. I just want to do SV. See if there's anything else open. Okay, so we can see that it's running OpenSSH at 8.3. And
Oh, that's where
Debian.
we get Debian.
Yeah, so sometimes
Okay.
if one thing doesn't give it up, you just got to get more aggressive with those scans. And if there's a couple scans in here that like Nmap people can feel free to drop the comments that are like particularly aggressive, that are
Yeah.
just like signs of you becoming frustrated with the box. They won't tell you what it is, and it's just like poking around and prodding it. Like eventually something will fall out.
Tell
And
me
here-
what you are. Gosh darn it.
Exactly. And here we can figure out that, it's Linux kernel, it's a Raspberry Pi, it's running Debian. That's a clue that it might be running Kali, because Kali is based on Debian.
I hear if you type harder, it works.
Yeah.
Better hacks.
Yeah, so now we have something else we can do. We've identified something, we've gotten a couple clues about it, and if I do, actually, let's see, nmap, SSH. So are there any other scans we can do? Let's just do some of these random ones, because I want to see as much as I can about this target. I want to see if we can actually provoke it into telling us it's a Raspberry Pi. So let's do -A.
What's -A doing?
Who knows? I'm just taking these from the bottom example. I'm just running them. I just want, maybe it means all. Fire all weapons. Actually, it seems like I have time, so let's scroll up.
Yeah, deploy all.
Deploy all weapons. Man, there are a lot of options, guys. Stay safe. Well, there's a capital A, but it's pretty, enable OS detection, version detection, script scanning, and trace route. Yeah, cool. Okay, whatever. So
We got some results.
yeah, we got some results. So yeah, still it's still identifying OpenSSH and stuff. This one seems to just have done a lot of work. So I'm gonna go ahead and recommend the A scan. It's a great scan, and I stand behind it.
Okay.
Raspberry Pi trading. Yeah, it's not really telling us too much else. Maybe I'll try this last example. IR. Yeah, cool. Do it. So the next thing we're going to do as soon as I'm done playing with Nmap Must be number of random. Yeah, I don't want to scan a bunch of random IPs. I've exceeded myself. All right. All right. So we've identified our target. It is 192.168.1.215. We've seen that it's running OpenSSH, and we have reason to believe that it is a Kali Linux system. So what we're going to do is we're going to use a tool I really like called Shitrix.
Okay.
Yeah.
Sounds like a good name.
Oh, it's real. So SSH -H. Option requires an argument.
Noise.
-help. Invalid host.
I feel like this is SSH tricks.
Man. There we go. All right, Shitrix. A very fast, multi-threaded SSH login cracker.
Okay.
Now, let's say that we have a piece of malware or even a hacker, but for the sake of piece of malware like Emotet, that's spreading over Wi-Fi, and it's managed to get access to a Wi-Fi network with a really terrible password. So once it manages to log in, it might run a scan of that network and try to identify things that are open, like this SSH port, and then run a cracking tool that's commonly available like this. So this is going to open multiple threads and attempt to crack this Raspberry Pi. And what we're hoping to do is be able to break into this computer, and without knowing the password, of course, we're going to hope that it's the default password. We're going to try to break in and probably just get it to reboot. Who knows? So, all right, let's go ahead and quit out of this. And we're going to start building our command. So how do we use Shitrix?
I'm assuming we have to aim it at an IP and then give it a password list.
Oh, it wants -H. I'm sorry that you don't like the way that I ask for help.
Yes.
Like, I'm sorry, do you even use the -lowercase? Okay, yeah, you use it for host. Whatever. All right. Me and the creator of Shitrix will have a conversation about this later. But basically, what we need to do is use the syntax. So we need to do -H to identify the host, and then we need some arguments. So the arguments that are available are a user list, a password list,
oh, yeah, I didn't think about
a username string, and a password string. So this gets complicated. If we don't know the username, that means we need to, for every username we try, we have to try every password. So very quickly, this begins to take a long time. But if we stick to defaults, then this can actually be a pretty economic attack.
And that's why I highly recommend disabling the admin login and like creating a user that is, like even Michael being a very common name would dramatically increase the security, because then you'd have to like brute force all the possible.
Oh, I forgot about this. I have to say, this is actually excellent. So if you just want to just duke it out, just go, like no learning, none of this stuff. You just want to attack.
Oh, just
it has a
D.
-D. So let's just try it. SSH Shitrix -H. We'll put in our target. Oh no, not that. I copied something by accident.
No.
Yeah. I need to just put in the actual.
When all else fails, use TAC-D.
Whoa, it's way up here. Where did it go? Here it is, 215.
Worst copy and paster ever.
All right, so that's the host, and then -D, right? Capital, yep. Okay, so let's see what happens. It's probably gonna fail. So we didn't specify anything. We didn't set how many threads, but you can see that it's going for it.
Okay. So I think the only reason it's going to be able to do this well is because it has a short password list of 79, right?
Yes.
Because if it had like a full, like even like a million password list, I imagine this would take quite some time.
Yes, and as you can see, it hasn't even got through the first 79 yet. So, and you're seeing cannot connect, error. Oh no, I'm a weak program and I'm sad.
Yeah.
It'll keep doing this. Basically, you just need to adjust and make sure. Oh no, it's really trucking along now. You'll be able to adjust this so it goes slower, faster, it uses more or less threads, and that's kind of how you'll calibrate this to make it work on whatever network you're on.
Yeah, I feel like
so. It's this poor freaking thing.
I don't know if this would actually allow you to do this, but I feel like it would be great if you could take like the million most common passwords organized by how frequently they occur and do like, okay, the first 100 of those common passwords on like all those users, and then proceed to the next 2,000. And so that way you're trying the most common ones first on all of them, and so that way you'd be more likely to get this faster.
Yeah, there's a whole science to like IoT malware also that constantly uses techniques like this to propagate to other IoT devices on the same network. So what they found also is that some of these will attempt this sort of process against Wi-Fi networks, where they'll just try to connect over and over and over and over with like the top dumb Wi-Fi passwords. Now, I really don't think it's going to get this because this password list is like quite large, and I'm not sure if the default credentials are even on here. But if you want to go ahead and take a crack at something you have permission to that you find on your network that has SSH open, then this will work. And in fact, I believe that Citrix also works for FTP, which is funny.
Oh, cool.
Yeah.
Is this the default SSH login for Kali?
Yes.
Okay.
What do you mean?
So is the Pi actually configured with the default?
The Pi has not been modified. It's just been set up with Kali Linux, so it's going to be the default.
So I would hope that a tool like this would have default.
It was fairly recently changed to Kali, so I'm not sure that it's been updated since then.
Oh, gotcha.
Or at least that I've updated this tool since then. So I'm going to assume that it's going to fail. So let's say that it doesn't work, and you're sad, and you're upset, and you don't know what to do. Well, fortunately, all the things that you need to know are in this great information that Citrix gave to us. Where is it? That's Nmap. So down here somewhere in this giant scrolly mess I have, you'll see that we can use the username string to we can use the username string to hard code in something we already know. So in this case, we know that if we put -L,
is it going to actually append that to the list, or is it just going to do that?
It's just going to do this one. We're hard coding in one. So we know that Kali Linux has a default username of Kali, but we're not sure if the password has been changed. So let's go ahead and provide a list. In fact, I'm going to go up a little bit, and I'm just going to go ahead and use this pre-seasoned one I prepared in the oven earlier. All right, so there are some additional arguments here. Let's see what they mean. So first we have -E. I don't know why this is here because it doesn't even work. So -E means I want to exit as soon as we find the first valid login. You can put this at the beginning. You can put it at the end. It doesn't matter. It doesn't work in any position that I've been able to ascertain.
Exit what? The terminal, or like
no, exit to stop the program. So without doing this, it will keep chugging along even after it finds a valid login. So if you have a million passwords and it finds it on the 10th time, it will not tell you until it's completely done.
I feel like that's just lazy coding.
This is a person that doesn't allow you to just type -H. They want you to type -H. What did I say about that?
A TAC H vendetta going on now.
I'm just saying, like, that's how you get to help. Like, don't make it. Okay. All right. So we also have a password list. So password.txt. So I'm going to go ahead and just copy this whole thing. And before we run it, I'm going to go ahead and show password.txt. So cat.
Yeah, weren't we looking at this earlier in the stream, I believe?
All right, so we have lots of different potential passwords. Yeah. All in all, we have, I think, like
I really want to know
or so.
Who uses that super long password.
It's like a default one, I think. 1, 2, 3, 4, 5, 6, 7, 8,
9. It's like
0. 1, 2, 3, 4, 5, 6, 7, 8. It's just a super long password that's just counting all the way up.
Yeah, it's just counting all the way up, like 10
So nestled somewhere in here is Kali, the very common default password. So it's not the first one, and we're gonna have to go through some in order to see. But you can see it's gonna try a whole bunch of different passwords, and we'll need to whittle through them in order to actually try that out. So what is the command we're gonna use here? Damn it. Of course I copied that. Why did I copy that? All right, here it is. All right, so we have the -E that's useless. We have the -H, which is specifying the target, 192.168.1.215. This is the Raspberry Pi we found. We have the capital L, Kali. So that's just specifying we're only looking for this username. Then we have lowercase k, which is the password list. And then finally, -T40. Michael, what's that?
Port?
No.
No. Time?
No.
T40?
Threads.
Oh, threads. Okay,
so what is a thread?
It's just like a portion of the CPU's power that can be run in like parallel, so you can have multiple threads working on the same thing.
Right, so we're going to basically attempt to create 40 simultaneous connections to the Raspberry Pi and all start trying to connect at the same time. A lot of them are probably going to error out, but just by being an octopus and trying everything all at once, like, we might be able to get through this list very quickly. Otherwise, we're going to be stuck here for a while. Yeah. So if we did this with one thread, it's not going to... Here, let's do it with one thread. It's going to suck. Watch. Boom. Okay, so all right, we're attacking. We're a hacker. We're breaking in. Cool, but it's going to take us forever because we're only using one thread. So good thing we have a fast processor
So what's
because
the
we're not using
limiting
it.
factor here on threads? Is it the Pi's processing power?
Well,
Or
no,
is
it's the network. It's the speed of the network, and then also the speed at which the Raspberry Pi is responding to our attempts to connect. So look,
Right.
we've tried 1, 2. It's been 15 seconds. What?
And there's only 201 passwords on this
There's
list.
only 2. We've tried 3 passwords. It's better than doing it manually. But hey, let's do multi-threading, huh?
Yeah, multi-threading seems useful.
Okay, let's stop this. This is painful. All right, so now let's go back and let's change the number of threads. Let's do 40 friggin' threads. Yeah?
Over 9,000?
No. No. It'll break. My computer will
Okay.
catch on fire. We're going to do 40. We're going to do 40. Ready?
Sure.
All right, let's go.
Deploy the weapon.
All right, we're at 30. Whoa! Okay, cool. All right, no, chill. It's fine. Just, I know.
That looks
I know
like
you're
a
upset,
boatload
but look,
of errors.
we're 60. We're 60 deep. We're 52 deep, and we've already found 1. So okay, so the program has successfully found a login,
But it didn't
but it's
exist.
not sharing it with us because that
That would be too useful?
that option is a little bit too shit trick to function properly. But yeah, it's we're almost there. So look at this. We've got a login, Kali. So.
Wait, okay, cool. I was like, it would have been perfect if it had said, "We found the login," and
just didn't show
tell
you. Yeah, no. This program's got some issues, like how to use the help menu. But aside from that, it's not that bad. Okay, so here's the moment of truth. Let's try to log in. So we have here the IP address that we found with our Nmap scan. So SSH Kali at and then 192.168.1.215. Yeah.
Cool.
Okay.
Port 202.
Are you sure you want to trust this computer? This
Yes.
computer should be asking if it wants to trust me. Yes. Okay, cool. Now it's asking for the password. All right, we found Kali,
What could that be?
right? And we have Kali Linux, absolutely no warranty. We will be something to the applicable law. Great. Okay, we're in. We've managed to get into our completely uncustomized Kali Linux installation.
Cool.
Yeah. So, all right, let's go. So this is the moment of truth. Let's go ahead and switch back to just us.
Okay.
And if I've gotten this all right, if we've managed to
Oh,
do this
yeah.
correctly, I
One
can
of
type
those.
reboot. And what should happen is one of these screens behind us, or both these screens behind us, should restart. So what we've done is we've started from just joining the network. We've scanned around. We've looked for ports that were open. We've identified a service we're interested in, and then we used a cracking utility to figure out what the correct login is. And now we're going to test it. So I'm going to do sudo reboot.
Moment of truth.
Password for Kali is Kali, and go. Connection closed.
Okay.
I'm so nervous. What's going to happen?
Okay.
Yeah. But all right, we've learned a lot. Oh, okay, it works. Yeah,
Yes.
see, it happened. It happened.
Totally. Oh, yeah, I see code running.
Yep.
Sweet.
All right, we did it.
Yes. Perfect.
So we have managed to take remote control of this computer behind us, this poor Raspberry Pi,
Mwah.
by scanning around on the network, identifying the Raspberry Pi, and identifying the service that would allow us to break in. And in fact, once we figured that out, we were able to take control of it by brute forcing the password. Now, what are the lessons learned here, Michael? What would you do to prevent this?
Fail to ban would be a
Yes.
first one. So that
What
would,
does that do?
So that limits you to X number of login attempts. So you could set that at 5 as a common one. So it would ban access from a certain computer once it tries to access 5 times or more and gets a password wrong. So fail to ban would be a good one. Doing it on a different port, I mean, it's like a speed bump for a hacker, but it's something you could do. Definitely disable the admin or default login and create your own user, and then also obviously create a secure password. Doing all of those things, like, it would be virtually impossible. Short of someone finding a post-it note with the username and password in your office or something, there wouldn't be a way to get into that, as far as I know, without like a 0 day or something.
Yeah, I mean, there's always things that you might miss, but in general, if you make sure to take common sense steps to change anything that's default.
Oh,
Get
yeah.
rid of anything that's
Use a
just
key
too
to
simple.
log in.
Use a key for SSH instead of just setting a plain text password that anybody can guess. There's people with a lot of time on their hands who, once they learn how to identify something, can go after it. And in general, it's a really good idea to make sure that if they do locate a device on your network, that it's not configured in a way to give them a really easy way of accessing it, because being the lowest hanging fruit is never a good idea. And of course, we need to reiterate that some of the stuff we've done today, such as brute forcing the password and logging in, could be a problem if you do not have permission to, or if the device doesn't belong to you. So while the first part of our presentation of just scanning around probably was legal, for at least for people in the United States, make sure that you do have permission before you go around trying to brute force your way into a service, because that will get you in a lot of trouble, especially if it is on a public network, a school network, a business network, a government network. Anything like that will get you in trouble. So just be safe out there and make sure that you have permission to interact with devices before you go about breaking into them.
Set up your own home lab. It's much easier that way, much safer that way. Always have permission. So
yes. All right. That's pretty much all the time we have today. Thank you guys for coming along with us. If you have any ideas for upcoming episodes, you can always feel free to hit me up on Twitter at Kody Kinsey. Michael is his legal name on Twitter, _Hoyd.
Yes.
And also, if you like this content, Varonis has a lot of other great stuff out there. In particular, we recommend the AD PowerShell course, which is a great way to get started learning how to script in PowerShell for Active Directory, which is where a lot of some of the more interesting corporate hacks happen. So if you're in a position where you're managing Active Directory and you want to learn to become more powerful with it, it is a great place to start.
Yeah. Don't forget to like, comment, and subscribe, and click the notification bell, and then you'll get notified on YouTube every time we go live. We also go live on Periscope, LinkedIn of all places, and Twitch.
Yep, but you can always watch these anytime. If you didn't catch the live stream, then you can go to our YouTube channel. All of these are saved there. And of course, we appreciate you leaving any comments, any feedback, so we can learn and make these even better. So cool. Thank you guys. I really like Nmap. So if you guys like this, just shout out, let me know. We can go even further, teach you guys some scripting with Nmap, how you can chain it with other commands. I love it. I could do a whole another hour on it. So yeah, thank you guys for hanging out, and we will see you next time. Bye.